All right, class, here we go. In the last video, we found our average angular velocity in radians per second, as you can see right here. In this particular video, what we want to do is the following. The first thing, you'll notice that we have all three of our rotations here. Rotational motion 1, rotational motion 2, rotational motion 3. Now, before I go any further, I want to make sure that you guys understand that I made an error in my on my scale, and so I left it at 1 meter. So I went back and I changed it to 0.1 meters to indicate 10 centimeters, like I actually did in the video. So let me go ahead and go back to number 1 here. And what I want to do is I want to take this and I want to duplicate it by selecting right here. So I'm going to duplicate this file. And when I duplicate it, I want to call it 1, 2, and 3. Okay. Now, I know that I was asking you guys to process all of that stuff in a separate kind of scenario, but I want to show you something. Let me just go ahead and duplicate the calculations that we've already performed. And let me give this a different name. And I'll move this over. And then I'll do the same thing. I'll just duplicate it again. And give it another name. And I'll just call this rotation 3. All right, so this should save us some time. If it doesn't, that's okay. So you have rotation 1. We know what that's going to be like. And so what we want to do is we want to go back and we want to get our data for rotation 2. And we just go back into our file here. And I'm going to go to rotational motion number 2. And I'm going to select out the data. And I'm going to copy it. So if you guys remember, we had time, we had positions, and we have velocity. So I'm just going to select the first 3 columns, and I'm going to copy them. I'm going to go back to rotational motion 1, 2, 3, and I'm just going to paste those in right here. All right. So what you notice is the calculation is done immediately. We have 1.5. It's about 15 centimeters. You know that already. So I'll do the same thing. I'm going to go back. And while I'm going back, Microsoft Excel and the iPad, they're saving things to the cloud automatically. So I'm going to go to rotational motion number 3, open that. Oh no, that's the wrong one. I'm getting ahead of myself. Let me go back to rotational motion number 2. Let's get our velocity information. Remember, we're going to copy that. Let's go back. Let's go back to rotational motion 1, 2, 3. And let's pop that in right here. So the colors should change. I'm just going to paste that. Very good. And so our tangential velocity should change and our angular velocity. And let's see what we have for our average angular velocity. Look at that, 1.885. Oh man, I put that in the wrong one. So since rotational 1, I'm just going to change this name. Dog it. Trying to be all logical. Oh, shoot, okay. So what I'll do is I'll say 2 here again, and I'll just move 2 over here. Call this something different. Don't even really have to do this, but I'll do it anyway. Yeah, I messed up, but I'm correcting right now. So I'm going to do 2 right here. So we have rotational 1. This is our original calculation, all right? And it corresponds to a radius over here that's about 10 centimeters. And then we have rotation 2. Oh, let me go back to rotation 1. So we have 1.88, and then we have rotation 2. It's corresponding to a radius of about 15 centimeters, and we have a different angular velocity here. But look, the angular velocity is already showing to be pretty much the same at both of those positions on the rod. So let's see if it's going to be the same all the way out to the end. Again, this one is just for 10 centimeters. So we're going to change this information by going back to rotational motion number 3. And I'll double click so we can clearly see everything in here. So we're going to take the first 3 columns and do the same thing. And this time I'm just going to try to slow down a little bit. I'm going to go back to 1, 2, 3. I'm going to make sure that I go to the appropriate sheet. And that's rotational motion number 3. So let's go ahead and paste this information in. All right. So notice that we're getting approximately 20 centimeters for the length of that rod, or 0.195 meters. Okay. So let's go ahead and go back and let's grab our velocities. Okay, and so we'll go back to 1, 2, 3. So we're in rotation 3. So those 2 are calculations, and I'm just going to paste it right here. So the calculations are done immediately. And look at our average angular velocity, okay, for rotation 3. Let's look at it for rotation 1. It is 1.88, rotation 2, 1.885, rotation 3, 1.884. So we're basically, these are facts that substantiate our preliminary hypothesis. So our hypothesis is good. We can continue on in that line of thinking. Okay? Very good. In the next video, I plan to do the angular acceleration, and I want to compare those as well.